Hello, everyone. Please confirm that you can hear me. Good morning.
Good morning.
Hi, good morning.
Morning. We can hear you.
Yes,
Yes, we hear you.
on the next 1 minute. All right. Good morning, everyone. I'm glad you all are joining us today in this section. This is officially our starting day. I know we met last week to talk about orientation and how to go about installing Python environment on your PC. And then I do hope let's also maintain the rules of muting our mics in the course of this until we get to the question and answering section. Yeah. Okay, so let's get started. I met a lot of you last week, and then I think I introduced myself. But by the way, my name is Daniel Lebo, a PhD student at the University of Cape Town, and also affiliated with the South African Astronomy Observatory. I myself and a few others helping to organize the BRICS Idea Data Analytics training, and then the cost of this very training is to provide training to early career researchers or astronomy enthusiasts or those interested in data analysts. We are looking at introducing data analytics to you, introducing how to analyze data, how to do perform statistical analysis, and how to do programming, basic programming. So in today's section, we're going to start with Python programming. This very section is going to assume that the majority of the people may have heard of programming or may not necessarily have the concept of Python programming. But This is just to make sure that we carry everybody along. So even if you've had some background, I believe there's also one or two things that you can learn or help correct others in the Slack community channel. So let's get started. So what's programming? Programming is a concept that has evolved over the years. So, but in a basic form, programming is the concept of utilizing a computer. It is a concept of writing instructions, telling a computer or manipulating a computer or programming a computer to be able to perform an action. A computer is a device, it's an electronic device that has the ability to process information. It can exist in different forms. Today, our majority of us see the concept of computer as maybe a desktop computer or a laptop computer, but our mobile devices are also computers. So in all of these devices, they perform certain actions, whether it is a calculator. The reason why they do so is that a program has been written, a set of instructions have been written in a way that the computer itself can understand. So this is basically the basic layer of programming. Now, programming also has different contexts. But one thing I want you to take out from this is that for each time that you strive to solve a problem or perform a task that requires a computing infrastructure, you are programming. And we can look at it from another perspective in the sense that I believe many of you do have operating computers. The reason you're able to connect on this lecture, or sorry, on this meeting this morning is because you have an access to a computer, either a desktop computer, a laptop, or a mobile phone. And you are actually interfacing with a technology that has been programmed to allow you to connect to the internet, to also allows you to be able to look at the information someone is sharing in a cloud service like the Zoom we are using this morning. So all of these things, the Zoom itself is a program, is a software that has been written using a programming language. Now, moving away from that, whether it is your text processing softwares like Microsoft Word or Google Doc, these things are softwares that have been written using a programming language. Then let's come down to our own area where we'll be talking about. So over the years, we've had many programming languages. So looking at this chart here, you can see a number of programming languages. This is not exhaustive. There are thousands of programming languages as of today. So, but you can see things like C, C++, you can see Ruby, Java, PL, Python, SQL, and many others. There are tons of different programming languages. Many of these are very ideal for different purposes. So, but we're focusing our attention on Python programming because that is the programming we'll be using for the rest of this training. Now, in the astronomy context, it's also important that we bring it down to astronomy. Many of us know that astronomy is the science that involves pointing telescopes to the sky to collect data, to collect extraterrestrial data from the sky, either from stars, galaxies, clouds, dust, gas, and whatever. Our objective is to do what? Is to take this data, analyze them, and generate insight from them. And how do we do this? It involves a number of things. You have to build a telescope. You have to point the telescope to a particular time in a particular region of the sky. You have to, instruct it to start collecting data. You have to also take note of the kind of data it is collecting and pull them into a database or into an archive. And many other things. At the same time, maybe this data is already available in the cloud. You want to process this data. These are different tasks or problems in astronomy. And this is not something that humans can just sit down and be doing all of the time. Yes, you might want to observe yourself. Let's say you have a telescope. You might point your telescope, control the telescope, but imagine you have to manually enter the coordinates all time and start pushing the telescope to go from one point to the other. Then you will see that you'll not be able to be efficient in this process. So programming has helped astronomers in the sense that developers have been, employed to write code that can help control these telescopes. A good example, for example, is this telescope. This is the South African Large Telescope. It is the largest optical telescope in the Southern Hemisphere. and majority of its operations are programmed. Yes, there are still humans who try to control it, but majority of what it does are programmed in terms of pointing to the sky, in terms of collecting data, in terms of analyzing the data, in terms of even doing a bit of data reduction. Another one is the new SK precursor. This is Meerkat telescope. One of the telescopes that is going to be part of the large SKA project here in South Africa. It's managed by the South African Radio Astronomy Observatory. Many of you may have heard about Meerkat. So Meerkat is also one of the newest radio instruments in the world. And it's also doing what? Doing observations almost all the time, taking data, storing this data. And you can see all of these telescopes. In all, Meerkat has 64 telescopes. Now imagine 64 people manning these telescopes, trying to point it into a direction that it's going to go in the sky. It's going to be a tedious task. So programming has helped astronomers in so many ways in terms of operating telescopes. Even today we have some robotic telescope, even at SAO here, we do have some robotic telescope that is purely controlled by a software that has been coded as programs. But I think I've tried to analyze, give you some concepts. Now let's go into Python programming. So I've explained before, why do we program? We program because we want to help ourselves maybe navigate certain problems that is a bit repetitive. So, if I know I have to, wake up this morning and then I have to maybe do some task, then if I think that those tasks is something that can be done in a computer, I can also program it. Even today in the era of AI, it is even becoming more easier that some of the tasks that we think were not necessarily programmed are now also being automated. So now, Python today is one of the common programming language. I did mention it last week, maybe for those who were not there. Why Python programming? It is one of the common programming languages. What do I mean by common? Common in the sense that it has been widely adopted by a lot of people, the scientific community, computer scientists, researchers, mathematicians, technocrats, economists, and the rest of them. Why? Because it is a bit easy to learn compared to other programming languages. It's also large, have a sort of community support in the sense that, somebody might write a script today that is very useful to solving a problem, and that code can be made available with documentation for other people to reuse. And then it is open source in the sense that it is arguably, even though it was initially developed by an individual, but it is open source in the sense that anyone can contribute to the development of the programming language. So that is the key thing about open source. It is free for everybody to use, and you and I can make contributions to it. So it is applicable to many fields, like I said earlier, whether it is in finance, whether it is in space, whether it is in astronomy, whether it is economics, whether in any field you can think of, it is applicable. Then in astronomy itself, it's also one of the most, in short, I said today, I think I would say Python is the most commonly used programming language because it's a starter, more like a starter tool to code or analyze astronomical data today. A lot of telescopes today building pipelines usually build their pipeline around using Python. So, and today we do have a number of very popular astronomy packages in astronomy used for doing different kind of analysis. Number one amongst them is AstroPy, which can be used for doing different kind of calculations, doing kind of maybe image analysis, light curve, many other things, mathematical calculations, simulations, and the rest of them. AstroQuery for easily navigating different data sources in astronomy or navigating different astronomical data archives. SpecUtils for doing a utility for analyzing spectroscopy, doing maybe something like, say, you want to plot a spectrum, you want to identify lines, some kind of maybe emission line or absorption line, measuring the equivalent width and many other things. So sorry, I'm going a bit high level, but I think I just want to also, a bit of entertain those who already have a background in astronomy. And for utils for doing things around photometric data where you have an image data and you want to analyze maybe things like light curve or get out an image, interpret an image, maybe get the magnitude, the pixelation, and the rest of them. So that's it. So beyond this explanation is very, very simplistic, but this is a good start into a motivation for you to maybe learn Python programming if you haven't. It can also become an easy way for you to learn about programming and also maybe move to maybe higher level programming like learning C or C++, for those that want to do some sort of, maybe now that we are in the era of AI, things like CUDA programming, which is largely based on what's it called? Largely based with C, C++. Okay, so let's just maybe touch a bit of I do call this core programming concept. It is generic. It is not necessarily applicable to only Python alone, but it's useful for Python. It's good to know in Python, but it can also be used. It also has the same meaning in other programming languages. So the first amongst them is a variable. What is a variable? A variable is how we store an information. Because the first thing, like I stated at the beginning of this course, is that programming, a computer does one thing, actually, processing of information, reading and processing of information. So some do have memory, some do not have memory. So now, what is a variable? A variable is to be able to identify a particular information in a computer in a way that we can tell the computer to manipulate it. So for example, I can say, oh, what is X? What is Y? What is my name? Oh, my name is Daniel. So how do I tell the computer that my name is Daniel? That is a variable. I already know my name is Daniel, but I want the computer to remember, I want Python or the programming language to remember that my name is Daniel. So I will have to do what? I will have to do that by creating a variable. And creating a variable means assigning a name to it. A good example is looking at this plot here. You can see X. X tends to 100. 100 seems to be in a box or a disk cube. And what we are saying is that this value is 100, and it has been assigned to X. So in that program, as it's running, whenever you call X, X will know that, oh, you are referring to 100. So this is a very simplistic idea, but I need to also let you understand that information stored in a computer can be of different types. Many of you know what 100 is. 100 is a whole number, and whole number is it can be referred to as an integer. So the program in Python itself will recognize that this 100 is actually an integer. I can change it later by saying X equal to, say, 200. It keeps note of it. So this is what, in a simple term, what a variable is. But then beyond that, we also have operators. Operators are ways for us to navigate or interact with variables or information or data in Python. Not just Python, but also to other programming languages. These things are also applicable in JavaScript, in Java, R, and many other programming languages out there, even some of the nuanced ones like Julia and the rest of them. So let's say, for example, let's look at the operators bit by bit. The first operator is plus. So in a simple term, operators sometimes are like mathematical concepts that are embedded in these programs or programming languages to understand how to manipulate data, or how to, yes, manipulate data, interact with data, play around the data or information that has been stored in the computer or that you want the computer to process. So plus, in real sense, is addition, just like in mathematics. On the other hand, we do have minus, or negative, for subtraction. We have the star for multiplication, forward slash for division, percentage for modulus. So this is just basically gives you a remainder or between two numbers. Like if I say 4% 3, it's going to give you 1, because if you divide 4 by 3, you're going to have a remainder of 1. So many of these things. Exponential is when you say, oh, raised to power. Double star is raised to power, and double forward slash is floor division. So floor division simply does, for example, if I say, oh, 5 divided by 2, it's supposed to give us 2.5. But then what the double floor will do is going to simply give you the integer value and leave out the decimal part of it. So these are basic concepts that I think is already provided for you in the Jupyter notebook that was shared last week. Plus, I do hope that many of you have gone to it. We'll get to it later, but we just want to introduce this concept. So again, variables are ways of storing information in a program, whether it is Python or whether it's a different language. The name variable is universal. Operators are ways of manipulating data in a program, in a programming languages. And the common ones in Python have been listed here for you. So, so moving forward, these two things are some of the core concepts that you need to understand. And I think moving forward, we're going to get into data types. So I initially came here and then I pointed you to X. Here, X is a variable and 100 is the value that has been assigned to it. So what this means is that if I say X in a computer, it's going to say, I don't remember what X is. X is 100. Okay, but that's not all. The same way we have, different things in life, we have different properties. So data too have different kinds of data exist. We have different data types, not just in Python, but in other programming languages. A number of these are also applicable. That will be discussed here, also applicable in other programming languages, but the syntax of representation might be different. So please do pay attention. So moving forward, everything we are discussing here is strictly applicable to Python. You might find them useful in other programming languages, but you need to also be cautious not to just apply it. If you want to learn about other programming languages, you can go read up on them or read up on their different data types. So what are data types in real sense? It means it's also about how we represent information. A good example, in the normal English term, we do know that we can represent, we have different kinds of data. If I ask you, you can say, oh, numeric data, numbers that are 1, 0, 1, 2, minus, blah, 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 real numbers, complex numbers and the rest of them. That's not the only type of data that exists, that can exist in a computer. We have text. We use things like word processing documents to write large chunk of text, or even this slide is all written in text. That's also a different form of data. We are live in this Zoom meeting. We have information being shared between you and I. I've been streamed. This is being streamed real life, and you are seeing me. And what it means is that there's a video exchange going through the internet and getting to you. That's also a form of data. That is video. And the other hand, we also have things like an image, like this. Looking at this figure here, this is an image. You can tell that this is an image, even though it's just like a schematic diagram. But image is also a form of data. And many other data that sit on your computer. If you go to your Files Explorer, you're going to see information. Go to desktop, go to even your computer root files, you're going to see different kinds of data, logs. These are all data. But in Python, there are ways to represent this data, or these are the commonest data types. First amongst them is strings. So what is string? We'll come to that later. So, but we have strings. Sorry, somebody's making an annotation. I don't know who is doing so. Please, can you stop doing it? I don't know, maybe please reset this. Let's not, yeah. So, so we have strings, we have numeric data types, have Boolean, which is a logic for true or false. How do we present logic in Python? We have tuple, which is also a way of storing sequential data. We have sets, we have lists, we have dictionaries. These last four are a bit. We're going to discuss all of this later, but just to touch on strings. Strings is just characters, character tests that in ABCD or in your own local language. Some of you are coming from different background, different tribes. You do have your own local way of writing, maybe in a keyboard and the rest of them. So those characters, they're all strings. It could be a representation of number, it could be text, it could be anything. The alphabets and the other special characters, they all fall into the strings. Numeric, like I said, is mathematical values. Yeah, mathematical values, integers, floats, complex numbers, and the rest of them. Boolean logic, tuple, well, let's go forward. So what is a string? Strings are ways of representing text or characters, like I stated earlier. If you have a text, somebody says, write a letter. What do? Or you pick up a paper, you write a letter. You can also write a letter in a computer. You can also write an essay. You can also write a proposal. All of these things are text. So if you want to represent those texts in Python, there's a way to do so. How do you do so? You have to enclose it in a quotation mark. So here is an example, name. My name is Daniel. Now pay attention to this. Name here is a variable. The equal to here is an assignment operator. And I have written this text. It could be anything, but I just use this as an example. My name is Daniel. My name is Daniel is enclosed in a quotation mark. Automatically in Python, Python will recognize this and keep this name as name. Let's say name is a variable. Just say name. It could be anything. You could just say, oh, maybe, oh, Dan equal to my name is Dan. You know, it could be anything you get, or his name equal to. So anything like that. So it will keep note of this. Now I say they are enclosed in either single or double quotes. Now imagine if I just come and write this like the way we can do things. Hey, name equals to my name is Daniel without enclosing it. It's going to throw an error. It is not going to recognize it. So so these are some of the concepts that you need to understand, especially for beginners, that if you are writing a string, you need to enclose it. In the Jupyter notebook that was sent out, you're going to see a number of examples like how to also manipulate and represent different kind of characters in a string. String can also be enclosed in a single quote. Here is an example here, today equal to May 14, 2025. You can see there's a difference between this first one and this one. What are the difference? In this first one, you do have double quotation. In this one, you have single quotation or quote. So these are things specific. This is how Python recognizes that this data type is a string. So you want it to be a text, a representation of text in the Python programming language. But then one thing I also want to talk about is that these different data types all have methods. So what are methods? Methods are functions that have been built in these data types such that you can also manipulate the data that you have assigned to a variable immediately in the language. For string, it does have a lot of methods. So as you can see here in this graph, in this image, this is an example showing different kinds of string methods. Now, to call any of these string methods, you have to do, say in this case, I say name. I'll just say name dot capitalize. You see, you just have to pay attention to the parentheses. You have to put it in that way. And it's going to do what? The first one here is simply going to take everything here and capitalize them, make them uppercase. You understand? It's going to capitalize them. And then on the other hand, you have case fold, we have center, we have count. So all of these things are available for you to access or play around with in your Jupyter notebook. In cases where they are not listed or the examples are not shown, I will appeal to you to try them out yourself using one of the examples in the notebook. Just try them out and try to understand how they manipulate the data that you have provided in the Jupyter notebook. Now let's talk about the other data type. Sorry, somebody is still making annotation on this. I don't understand why. Please, can you stop doing so? And I don't know if Label or who is here. Please check if you can manage who is doing this. So and for the numeric data type, so numeric it's just more like a combination of the other data types. But I just want to put it in categorize it that way so that you know that these are all fall into numeric data types. So we have the integer data type. So what is an integer data type? Integer data type is nothing other than a mathematical whole number in mathematics. That is a number that has no fraction beside it. I think that is the simplest term you can use to describe what an integer is. So it can be negative, it can be zero, it can be positive. But the most important thing is there is no fraction, whether decimal or appending a fraction to it. A good example is year is 2025. This is an example of an integer. So in this case here, you will see that year has been represented as 2025. And if you call year in Python, it is going to tell you 2025. Zero is now represented as the zero number. NEG Just, just an example I'm giving, just like say negative is saying, oh, this is minus 20. So it keeps track of these values that you have assigned to them. So when I was talking about variables, I know I wasn't exhaustive in variables. So there are ways for writing or defining a variable. Many of them have been described in the notebook. I think when we go over to the notebook, we'll touch a bit on that. So there are built-in Python functions for probably converting a value to an integer. Let's say, for example, I say, I put 6 with quotes, and I define it as maybe SIX6, and I want to convert it to an integer. All I need to do is just call int, short for integer, and then in this parenthesis, I put the 6 inside, and then it automatically converts it to a 6 in a mathematical 6, number 6. So we have floats. Floats are numbers that have pointing values, that is numbers with decimals around them. It can be negative, it can be positive. A good example is half, 0.5. Magnitude, say, let's say, what is the magnitude of a star? We say maybe a star that has a magnitude of 12.7, maybe V magnitude, G magnitude, or whatever. You can say has a value of 12.7. A pi, the one that we're so conversant with, the constant, mathematical constant, is 3.1415, the ending values. We just shortened it here. So pi is a float. And then supposedly you have a value maybe enclosed in a string or in a different format, and you want to convert it to float. You use the function, built-in function float, to be able to convert it to a float pointing number. We have the complex number. Many of you have done calculus or advanced mathematics or further mathematics, and then you will hear the term complex number. What is a complex number? Complex numbers are numbers with real and imaginary values. So they tend to have this sort of imaginary value, where the imaginary value tend to have a value with the minus 1. You understand? Square root of minus 1. So you have it here. How do you represent it? You have to, if you want to, the complex feature or the imaginary feature, you have to attach j to it. Here is an example, z equal to 3 plus 4j. And here 3 is the real value and 4 is the imaginary number. And we also have a complex function for converting an object to a complex value. So you can see how there are patterns to this. These things are not exhaustive, but we're trying to give you like a tidbit of how these things can work. So I will implore you to try these things out on your notebooks and see the kind of things that the kind of results you will get. Play around them. That's actually the easy way to learn. So let's talk about the other types of data tuples. These are more complex data structures that are very, very useful and is very, very applicable in multiple fields, in astronomy, in data science, and the rest of them. And we need to talk about it a bit here, but not exhaustive, but just to give you a tidbit. Tuples are ordered non-mutable sequence of numbers or of values, or numbers, or values, data, information. But what distinguishes them out is that they are enclosed in parentheses. So, the normal bracket. An example here is these items. You have this value here. You have this the parentheses, you have physics is awesome, 12. So these are all items. 1, 2, we have 5 items here. 1, 2, 3, 4, 5 are all items. So physics here is a different data type. What data type is this? This is string. Is a different data type, a string. Awesome is a different data type. Yes, this one is in double quote, is also a string. 12 is a different data type. It is an integer. 3.142 is this, constant, pi constant is what? It's a float. So you can see at least we have 3 data types in this tuple. So what you can sense from tuple and the rest of the other data types we're going to talk about is that they can contain multiple data types. It's a way to enclose different kinds of data, whether text, whether numbers, you understand? So that is what tuple is all about. Tuple do not necessarily have a lot of methods. It does have only 2 methods. Unlike string, you can see string here has a lot of method. I didn't talk about floats. You can check those ones out. They do have their own methods too. Tuple do have just two methods. Count method for counting the number of items. Say if you do items of count, it's going to tell you, oh, I do have 5 items in mint. Then index is when you want to find out, supposedly you say, oh, I can do items.index, and then I put in is and say what index is in. It's going to tell you 1, not 2. I think maybe that's if probably some of you may have seen it in the note that there's a way Python indexes values. It doesn't start counting from 1. It starts counting from 0. So there are many languages that does that way. There are many other languages that start from 1. So, but there are common functions that are inbuilt functions in Python that you can use to apply to tuple. A good number of them is len. So len is a function that can help you count how many items are in this tuple. Max, supposedly this tuple is only made up of numerical values. Max is going to tell you the highest value in it. Min will tell you the lowest value. Supposedly this is made up of only numerical values. Sum is going to perform the addition of every value. Supposedly it's a numerical value. Sorted is going to sort the values starting from the lowest to the maximum value. So, so these are functions, inbuilt functions that are already in Python that you can call and use it to perform manipulations or get additional information. We also have the tuple function itself that converts an iterable object to a tuple data type. Supposedly, I have this as square bracket, which is a list. Tuple can take ownership of that and convert this into a tuple. Now, let's talk about list. What is a list? Lists are mutable sequence of items that are also used to store information. They are different from tuple in the sense that tuples are not mutable. So what we mean by not mutable, you can't simply change values or don't maybe replace a number for tuple. But for list, if you have a case where you want to store information that you think you want to change regularly, then list is your guy. List is your guy. So it's a mutable sequence of items. So you can see I've used the same example in the previous one for tuples. The same thing we have here, items, but pay attention, what it is enclosed in what square brackets. So that's the only difference. But then it can be manipulated. The values can change. Now, tuples are also very beautiful because it can also store a type of its data in itself. If you look at the second example here, my list, you see that we have just 3 values in this my list. In the first item, we have 5 in the first items variable, we have 5 items. In the second list example, my list, we have just 3 items. We have the first item, which is an integer, and then we have the second item, which is a list that has 3 items inside of it. So how do I know this? You have to look at the separations. The comma is what separates them. So this is the first one, and then all of these are together. That they make up the second one, and we have a float as the third one. So I want you to look at this critically and pay attention into how you can see that data can actually evolve, and data can actually be stored in different form depending on the complexity of the data. So to convert let's say an iterable object to a list, let's say you have a list or a set and you want to convert it to a list, you just have to use the list function. It's an built-in function. You don't have to install it. You don't have to import it. If they are already inbuilt, just call them and then they perform the operation for you. On the right here are methods, callable functions. When you create a list variable, these are methods that you can call. Apologies, these are starting with the first letters are uppercase letters, but please, they are all lowercase. Whenever you are calling any method, they are usually lowercase. Append is going to add another element into the list. So let's say I have defined items and I want to add a different thing. I can say items, and then I want to add, say something like star. I just say dot append, and inside it I'll put a string with star. It's going to append it to it, insert it there. We have extend, which will also add all elements of a list to another list. So you have a list and you take another list and then you extend. It means it's going to take this list and expand and include the other items in the list. Insert is just going to take, say, a particular position. In this, maybe I can say, oh, I don't like this physics, and maybe I want to replace it with chemistry. I want to replace it with astronomy. I can just say items dot insert, and then I will specify the index where I want, which is 0, because this first item here is 0. And then I put comma, and then I add in the name of the value that I want to use to replace it. Say astronomy, say chemistry, say whatever, say mathematics, and then it replaces it. So next time you call items, it's not going to be physics, it's going to be maybe mathematics, chemistry. So the same thing is applicable. So there are a lot of this that you can use. I will implore you to play around them each time, because again, for each time you play around them, you have a better understanding of what it does. Then let's talk about set. Set is also another type of data, a data type in Python, which is also one of the ones that also have enclosed features. So set, oh no, okay, sorry, I've seen that there was a mistake here. So sets are usually enclosed in what you guys call curly brackets, not square brackets. Apologies, this is supposed to be curly brackets. So I think we have an example down there. So you may have seen it. This is a bit of an error. My eyes did not catch it. So you can see set. So irrespective of the fact that maybe this has been defined this way, if I truly want to convert it into a set, all I need to do is just say items equal to set items, and then it will give me back the items. So they do have their own methods. Which is add, sort, sorted, remove, discard, update, min, max, and pop, clear, and these other ones too. But there's one unique thing about set that I must say. So if you create a list containing values, multiple values, and you're looking at how to just create unique values out of the list. Let's say I have physics twice here, awesome, tries, and many others. And I want to just take the unique values. Set is the best bet to just pick out when you convert that list to set, it automatically pick out at least only the unique values without repeating them. So that's just one unique thing about set. It is not used very often, but if you are dealing with a case where you have to deal with unique values, set is very, very useful, helps you to do so. And then just like setting mathematics, you can do things like union, intersection between two sets, and many other things, the difference, the complement, and the rest of them for sets. So let's talk about dictionary. So this is what I'm referring to as a curly bracket. So this kind of bracket is a curly bracket. So that's actually how you enclose a set. Okay, let's talk about dictionaries. Dictionaries is one step ahead in terms of storing data, or storing information in Python. It evolves, it operates using the key value pair. So you don't store information, you store it as a pair. Example is that, just like the way a dictionary itself means. What is a dictionary? A dictionary is a document or book that provides words and their meaning. You understand? So what is a name? A name is what you can use to describe, explain, describe someone, or something like that. So it gives you a sense of meaning. So it is a kind of data type that tries to give meaning to a word or to a term. So just have it like that at the back of your mind. So a good example here is my date. Oh, name is Thomas. Age, 13. Subject, physics. Now, this is showing you something that they exist in pairs. Pay attention to where the comma starts. This is a string, name, and you have a colon, right? And then you have the definition. So this is the key, and this is the value. This is another key, age, and the integer, 13. That's say 13 years is the value. Subject is the key, and the subject name, which is physics, is the value. Here's another example. You can see that this is another way to create a dictionary. You say A dict A equal to 2, B equal to 4, C equal to 6, D equals to 8. So what this will do is that if you call D again, it is going to represent them in this form, where A will be in this form, 2 will be in this form, things like that. So if you also want to, you also have the dict function in Python. You don't have to import it, where you can use to create a dictionary for my iterable object. It does have its own methods like key, clear, copy, keys, get keys, items, pop if you want to remove an element from a key, and many others, or if you want to update any information in a key. So play around this. We have an example on dictionary in the Jupyter notebook that can enable you understand this, create more cells and play around, try out these keys, these methods. And then we do have, so please, we're going to keep, I'll probably suggest that you note down your question so that at the end of the section, we can go over it. Let's maintain this flow. So we have the control flow. So what is a control flow? We do have a case where things are sometimes a bit repetitive or are conditional. So this is where logic plays out in everything that you do. A good example is, or maybe you let's say you're a student. Every morning you go to classroom, you go to class for lectures. Maybe you go to class, say 8 a.m. in the morning or 9 a.m., depending on the time of the class. And in a particular time of the year, for example, in Cape Town, now we are in winter. So what it means is it can be cold, it can also be windy, it can also rain every now and then. So now these are conditions. Oh, I have a lecture today by 9 o'clock in the morning. I come out, I check the weather. Is it going to be cloudy? Is it raining? Is it sunny? Is it windy? So this will enable you know how to dress up and go to school. So these are conditions. If it's raining, what do you have to do? You have to pick an umbrella. You have to go to school with an umbrella. If it's too cold, you have to go with your winter jacket. If it's sunny, you have to go with maybe a light jacket or just not with no jacket at all. So these are conditions. You understand? We also have cases where sometimes things can be repetitive, where you need to, I have a list of items, and then I want to calculate, let's say, for example, the planet in the solar system. You want to calculate their distances, say distances from the sun, or you want to calculate a particular parameter from it. You have one value, you're looking for how to do it for the rest of them. You don't need to start writing a particular function or mathematical relation that will be doing it one after the other. You keep writing multiple lines, you understand, just changing one value. It can be tedious, especially when it is something that is very, very long or something that is very, very large scale. So how do you navigate problems like this? This is where you have control flow. You understand? Logic to say, given that these conditions are met, please perform this operation for all of these items. Or given that the weather is sunny, not going out with an umbrella. Oh, if it is sunny, go out with an umbrella. These are conditions. So there are multiple ways of doing this in Python, or not just in Python. Some of these things are also applicable to other programming languages. Commonest among them is the if-else condition, or else if. So the if is where the logic comes in. If condition. Then if the condition is met, execute. Then you have a case of for, where you might want to do calculation for, like I said before, but you might want to say, you're taking record of maybe calculating a parameter. What is maybe you are told to calculate for different stars. The mass of the star or the rays, and you are told to probably calculate the gravitational force for maybe 100 stars. What do? There's a mathematical function already that tells you the relationship between gravitational force and the mass and radius of a star. And maybe you already have the mass and the radius of the star. There's a gravitational constant that you need to plug in, but you need to do this for multiple stars. So you can just write your code and say, given all these masses and radius, please calculate all of these values, calculate the gravitational force for me in one go, and it's going to do that. So that is what the for loop does. So it loops through ranges of values to do that for you. So the while loop is also the one that is very, very essential in the sense that, while this condition is met, I want you to do this until maybe when it gets to a particular condition that you do not like or that is not met, it stops. You understand? Okay, a good example is, let's look at this from an astronomy perspective. An optical telescope, majority of the time, in short, it's not majority of the time, it's used if the weather condition is good. It's used at night. It's used in the night for optical telescopes, even infrared telescopes. So what do you do? Let's say you are an astronomer and you are using the telescope for observations. And after twilight, you start pointing the telescope to the sky. So you can write a code and say, while twilight and every other condition is met, like maybe not raining, open the dome. You understand? Open the mirror, open the dome, open the mirror, and point into the sky. Maybe keep pointing to a region of the sky, taking data, or keep pointing from multiple places in the sky, keep taking data until morning twilight. So morning twilight tells you that the sunlight is already coming, and you know that sunlight is not good for the telescope, can damage the telescope. Close mirror, close shutter, and shut down. So for the majority of the times we've gone to observe and use the telescope, these are some of the things that we do. But these things can also be implemented in a code, especially for robotic telescopes. That is what it does. You check the weather condition and say, while the weather condition is met, while after twilight and a bright sky, open up, do your technical work. When you're done, when this condition still shows up, or these conditions are no longer feasible, shut down. So these are the very simplistic ways that I can explain this. And we do have examples in the notebook that demonstrates how to use these examples. Then you have the list comprehension, which is, I'm not sure if it's in the notebook, but I want just to point it out in the sense that it is also that is where a case where the looping method is very useful for manipulating data in a list. Supposedly you have a data in a list and you want to manipulate it. You can easily say, okay, I have a list of numbers, say 1 to 100, and I say, I want to calculate the square of the values. What do I do? I can run a simple operation inside the list itself, and it's going to calculate the square of the values and still save them as a list. It's one of the common ways or some of the common manipulations you'll be doing in Python. So, but that's by the way. I think we're spending a lot of time on this, so we need to also quickly go to a bit of the hands-on section just to play around with some of the notebooks. So we talk about function. What is a function? So you can see we are gradually moving from variables, operators, data types, control flow, and then functions. So function is where you get to as a beginner who is learning programming. You need to understand some of the core basics that I've mentioned in the past slides. And then you need to get to a stage where you need to start doing real programming in the sense that you want to be able to write programs, instructions that the computer can understand and that can be reused for other tasks. That is what function does for you. Function allows you to write a code that can accept data, that can allow you to manipulate data or perform certain operations on the data, and such that the function can be reused again by either you or someone else if you choose to share your code. It can be reused by you or by someone else if you choose to share your code with someone or a community. So in this slide, you can see a very simple example. Look at, they wanted to pay attention to this side, to the right side of this. There are ways to define a function in Python. This information is already there in your notebook. The def keyword, DEF, maybe short for define. Some people say define function, is used to define a function. So after the def keyword, you're going to have a space and the name of the function that you want to define. This is an example. The name of the function is add. So from mathematical concept, simply say adding two values. It can be two or more values. So here is what we call parameters, because a function accepts parameters. There are some functions that do not have parameters, but some very useful functions do need to have parameters. Now, parameters means that the values can change, but the operations are the same. In this case, num1, num2 are parameters. Now, what it means is, this is saying, take these two values, print them for me, print the first one, print the second one. So you're using the print keyword to print the first one, print the second one, and then now perform the operation, which is creating a new value that sums these two numbers together using the plus operator and return the addition. So return is a keyword that is usually inside a function. It's a property, it's one of the properties of a function. So this will return addition. For you, a good example of a function, default function that you have in Python that you don't need to install or import is the sum function. The sum function performs addition for you. It takes a list of mathematical values, and what it does is, whether it is 100 numbers there, whether it is 200, it's going to sum everything and returns the sum for the summation for you. So this is how you call the function. So this is all the function body, and this is how you call the function. You define a function first, and then before you call it, you don't call it, you have to define it first before calling it. That is how your program is going to recognize it. So this will call the function. You pass in the parameter inside. In this case, 2 and 4 are parameters. So I'm guessing that you know that if you run this on your computer, it's going to print 6 for you because 2 plus 4 is 6. So this is in a simple or simplest term what a function is. We do have a function notebook there that talks about different how to write a functions, the rules for writing a function, and some examples. You understand that also applicable. In high level, you can begin to think about putting in things like, exceptions, error management, so that maybe if supposedly I say 2, comma, and then I put 4 as a string, it's going to, through an error that, oh, this is not actually an integer or a float. This is maybe a string, and you cannot add string with an integer, things like that. Or these are like high level, but this is just a good start for people who are beginners in programming. Now let's go touch about classes, and then we quickly run to the notebook. So classes are other ways of also writing codes that are reusable, but they are a bit higher level than a function. So it allows you to create an object. And what do we mean by creating an object? Creating an object in the sense that the object or the data or the function itself can be reused in such a way that it can have many properties. A property is in the sense that the properties like attributes, or it can have multiple functions. So, so class is a kind of Python framework that allows you to have defined methods, the same way you have been using methods. I think right here, we did talk about methods like this set methods, dictionary method, list methods. So if you want to write these things, as a result of the fact that these things are written as Python objects or classes. Remember, pay attention to when I say objects. So now if you want to create your own objects, you have to do so with classes. And if you want to have properties like methods like this, you can also do so using functions inside the classes. Now let's look at this example. This is just, I think this is part of what you have in your notebook, is just telling you that you have a book class. In this book class, it has attributes. What are attributes? Attributes are no other things other than, say, the variables that you have defined inside the class. Those are the attributes or the parameters. If you may choose to call it that, we'll call it that way. Supposedly you have a bookstore, you have title, you have author, you have pages, price, maybe you're selling, well, what's the discount? And then it could also be a library or where people can come, hire a book and read, and the rest of them. So you can also maybe where they have metrics like, oh, you can, for this book, I take you, say, 8 hours to finish reading the book, 12 hours, 24 hours. So those ones are methods. Or you want to see if the book has a discount. These are just manipulations or methods that have been described to say, oh, please check if this book has a discount, apply discount. So those are linked instances. Now, looking at this example you do have in your notebook, we've created a class for you here called Planet. So this is just a very simplistic class object, a class object where planet has been defined. And it has two attributes, the name of the planet and the mass of the planet. So this keyword, pay attention to the structure. You have the init, double is like double underscore, init, double underscore. And you have the parentheses where it takes self, name, mass. This is how you create an object. This is how the objects are created in a class. So that is what differentiates a class and a function. And you assign those attributes to the self.name, self.mass. So in this case, you have created the attributes. Now, supposedly you want to create the method. So methods, what is a method? Methods are just functions on how to manipulate the object. Here, you have a very simple example, which is just a string thing that doesn't do any calculation. So it just does the printing for you. It says, taking the object or attribute of this object, inherit the other object, and print the attributes for me, print the name and print the mass. Then when you are done, you create an instance of your object. In our case, Earth is a planet. We define the name and we define the mass. Mars is also a planet. We define the name and then we define the mass. And and then when you run it, this will give you values. If you say earth.describe, in that case, you are calling the method function, the method attribute, the method, which will just describe the properties for you. In that case, it's also to say planet Earth, has 1 mass, or planet Mars has 0.1 mass. So this is how these things operate. But then I do need to highlight one more thing. I do think this is very, very important for you throughout this learning journey, because these are very common things that you might want to have at the back of your head and make use of, that you might probably make use of all of the time. For some of you who have already started, you must have seen the print statement. It is the most common example because we want to show you the functions and what is happening. Because you want to see the results that the program is doing. You want to be able to display it. So print is an easy way of displaying the result. Let me say you do something or you want to print a variable, you define a variable, but you want to confirm if the variable has been recognized by the computer, you simply do print and it prints it for you, it displays it for you. Learn will calculate the number of items in a list, you understand, in a sequential data type. So whether it is a string, whether it is a tuple, a dictionary, a set, a list, it is going to run through, perform the iteration of calculating how many number of items in that very object. Type will tell you the data type in the object. So if you define a data and you don't know the data type it belongs to, you can quickly check with type. Range allows you to generate a range of values. So range, when you say range, you can say, oh, what's a value between one to another? So range allows you can say 1 to 10, and it generates value from 1 to 9 for you. And then open is another function. These are default functions, so you don't have to import them. You don't have to import them or install them. They are already built. Allows you to open a file. The open function allows you point it to a file on your computer, and then it allows you to open that file. And then you can call or read the file or read the data in any shape or form that you want. Now, this, as a beginner, these two, help and dir, are very, very essential. Help is a function that allows you to quickly read documentations, information about a function or an object in Python. I will show and do a demo in the notebook. So if you are confused about something, or you created a list, you're confused about it, or confused about, hey, what is a list? Maybe you've defined a list and you're confused about it. Maybe what does this thing mean? You can quickly use help to passing the name of the variable, and it gives you information about it and tells you that information can now tell you more about that and how to maybe go from there, manipulation. So the dir is an essential. When I was learning Python, it helped me a lot in the sense that supposedly I'm not so sure of the methods available in an object or in a function or a class. I can quickly use dir, and it is going to list all the available objects. And then I will know the right one, attributes or methods. It will allow me to know, okay, I need to call this or call that. Zip, it's a way of iterating iterating a sequential data. So it's not just, sorry, I say tuples here, it's not just applicable to tuples. It can be used for lists, just any of those sequential objects. It does allow you to navigate through it, like, oh, let's see what's in the list. It iterates like, oh, first item, second list, first item, second item. You can just say I, comma J, and then it does first item. This is what is in the first item, second item, this is what in the second item, and the rest of them. So I think these are the common things that that you need to pay attention to as a beginner, and that will also help you in the course of your learning journey for Python programming. This is not exhaustive. Let me point this out again. This is not exhaustive. This is just for you to give you a tidbit, because I believe many of you are already looking at the notebooks. Maybe some things are confusing you, and then this lecture is just to point out maybe some clarity. So I think that's all. Now we can move over to the Q&A section. So I would like us to have interactive questions here as we progress. But I don't think we need to do this now. Oh yeah, let's quickly do the Q&A then before we go to the notebooks. So any question? Okay, thanks, Madho. I see.
Hello, sir.
Yes.
How we are going to implement all these things? Means, are you going to teach us all these things?
Please. Can you do
How
what?
we are going to implement all these things? Are you going to teach us to implement all these things, or we have to learn on ourselves?
Okay. First question: do you have access to the notebooks that was shared last week?
Yes.
Have you opened them?
Yes. Yes.
Have you? Did you have Anaconda installed?
Yes.
Have you tried to run any of them? Because
no, not actually.
Okay, cool. Okay, cool. So I think we can get to that because those things have been pre-built for you to read and also run them, and then you will be able to get a sense of what we're talking about. Okay,
Okay.
any other question?
Yeah, good morning.
Yeah, good morning.
So my my machine, it's 2015 MacBook Pro. I tried installing Anaconda. It would only install only just the Python IDE. I tried using the directory that you gave, but it always came down to just the IDE.
You can access Jupyter Lab or Jupyter Notebook,
Yes, I can't access them.
but did you install Anaconda?
Yeah, I went to the Anaconda official website, and the options I got there was just installing just Python itself.
Did you
But
use the link that I shared in the documentation and the presentation link?
no, I only typed the official.
Yes,
No,
that's the instruction. If you click the link, it will take you to the installers that you download. What you are using Mac, right?
yes.
And then you said your Mac is 2015, so you need to download the one for Intel. You have to download the one Intel graphical installer. If you download it, it should be able to install on your PC without any problem.
Okay.
Yeah. Any other question? Okay, thanks to those helping to answer questions on the chat. That's a good one. Okay, yeah. So I think, oh yeah, I'm seeing this now about where do you want to submit assignments, exercises. So please do the exercises in your notebook, and then over time, again, I think I said this last week for those who didn't join. We'll be doing focusing more on projects, because we do not have enough resource to grade all of the assignment, but we appeal to you to try and do the assignment, because that is the only way you are going to learn. And again, you need to also ask questions or form a group, and then maybe interact amongst yourself to see if the assignments, the exercises that you've done are correct. So I see Nagesa, I don't know if I pronounced your name correctly. If you can speak now.
Sorry, I missed to get the notebook you sent before. Maybe I may
So
not
the
receive it.
notebook are you in the Slack channel? Are you in the Slack group?
Yes, I'm add myself in Slack.
Are you in week 1 channel? Are you in the week 1 channel?
What channel?
Week 1 channel.
I don't understand that. Which
Okay,
one? Is this one? Okay.
Yeah, I'm sharing this now. So last week, I'm not sure if you joined or if you watched the video. If you watch the video, you should be able to see in the Slack, we do have this in the Slack, we do have multiple channels. So you need to join the week 1 introduction to Python channel. And how do you do so? You need to come here in channels, go to manage, go to browse channels, and then you'll see all the channels available. See, this is week 1. You will join it, and then you will see the information there. It's still there. It's not taken away, so you can access it. So let me go to the channel here. This is the information I shared. All you need to do is to scroll up. You see week 1 resources.zip. So it's a zip file. You unzip it, and when you do so, you see all the notebooks there. Okay, Magesa, are you still Magesa?
I will look it back. Okay, doesn't matter.
Okay, cool. Any other question? Okay, thanks very much for this section. So I think we need to go over to the Jupyter notebooks. For those who went to the GitHub repo online on GitHub, this is the GitHub repo here. We do have the week 1 resources here. In the week 1, we have all the notebooks. And this is for those who are having problems or challenges navigating or installing a Python installer or IDE or whatever on their computers. One option that you can also do is to start with running this. If you have access to the internet and a browser, you can also make use of Google Colab. That means you have to have a Gmail account, a logged in Gmail account. So a good example, we need to start from this one. Variables, which is what I talked about this morning.
Can you please open one?
Sorry, I can't hear you.
Can you please open one notebook and let us see how we can.
Yeah, of course, that is what I want to do. So we are in the variables section. So go to variables and data types. Here you will see this button here, open in Colab. If you click it, it is going to open in Colab for you. But you must have a Gmail account that is logged in, because it requires your Gmail for it to open on Google Cloud Service. So, and it is free, so you don't have to pay. So here you can see the same notebook. Yeah, you can see this is the same notebook. This is now opened in Google Colab. Automatically, the Google Colab knows that this code is running in Python. This is a Python program. So you don't have to do any installation. All you just need to do is to start running the notebooks. So you need to read through. I believe everyone here can read English. You read through the text, and then you play around. This is an example of defining a variable. We say a variable is a common terminology in programming for storing information. In Python, a variable is a symbolic name that references or points to an object, just like the example I showed in the slide. Now, if you want to create a variable, how do you do so? You start with a variable name, you define the variable name, you use the assignment operator, and then you pass the data into it. In this case, our data type is a string. For the first time, just play along. The data types will be described later, either in the notebook or in the next notebook. Now, how do you run this? If you are running this from your Jupyter notebook, and let's say you create your own local server with Jupyter notebook on your browser, and you open this notebook. If you want to run it, you can simply do Shift Enter. There was an example in the first notebook there, Shift Enter. So if you run Shift Enter, this is because I'm using Google Colab. So you are going to get this warning from Google. It will tell you that this notebook was not authored by Google. And then we'll ask you if you would still want to run it. If you trust it, I want to run it. You just say run anyway. So immediately you do that, it starts connecting to a cloud compute on Google Cloud Platform. This should not take more than 20 seconds. You can see it is connected. And then you're good to go. You say it marks good. Now it has run this for me. It has run this cell for me. Immediately it does that, you can see it has assigned it 1. Pay attention to this play button. If I move over it, you should be able to see similar thing on your normal Jupyter notebook. So you can see the 1 is showing there. You can see a square bracket 1. That is a sign that it has run. It shows it marks good that that cell ran successfully without any error. Okay? Then if you continue to read the text, so these are cells. The ones that are a bit grayer or darker than the whiter one are the cells. Those are the ones that you need to run. If you want to create one yourself, you can just come up here and create, click the code, and then it creates a new cell for you to run. I can say *2. You want to maybe say AR score is a star. And then if I run this, it runs successfully. Now, if I do something like this, because I'm trying to create a string, I did not enclose it. I opened the first enclosure, but I didn't close it. You are seeing this already, showing a sign that something wrong with this code. If I run this, it is going to throw an error. It's going to mark this as red. This is for beginners. And then it's going to tell me a syntax error. You are a beginner. You may not necessarily understand all of this. So I will implore you to just, but in this case, you already know that the cause of our error is because we did not close this. So one thing about programming language is that they don't assume. They don't assume. You have to feed them the right information for them to operate. It's not going to infer that, oh, you mean this is a string, but you did not close it, then it will close it for you. No. So you must explicitly type in the character. Okay? You must explicitly type in the character so that it can be able to recognize it and do the right task for you. So now I've enclosed it. If I run this, you can see there is no error anymore. I can come here and say, okay, I now have created a new variable called *2. I run it. Automatically, Jupyter notebooks, when you put the last thing in a cell, automatically prints for you, even without using the print function. It will print. But supposedly I now come and then I have defined star2, not star. I now say star. Star is a variable, it's supposed to be a variable name, but it has not been defined. If I run this, it's going to throw an error to tell you that it knows that you are referring to a variable. It tell you this is a name error. Name star is not defined. So you have to go back and look at your previous code and see if they all align together, if they are exactly referring to the same thing. Again, Python is case sensitive. If I say a star, I can type it as
ماذا؟
and then T. You understand? Let's say I do this.
ماشي.
Sorry, hold on, please. And then you
لا
do
كيرا
this.
ليش؟ آية تشجرون؟
Sorry, who is speaking? Can you mute your mic, please? Now you have this star. And then when you run this, it tells you star is not defined. Why? Because we did not define the variable in this character where one of the character is uppercase. So it's not going to infer it for you. So these are some of the things that you need to have at the back of your mind. So to get this to work, I just need to put it in the exact way it is before. And then when I run it, it prints. It displays for you without any error. So these are some of the problems we are going to have, because if you are typing these things yourself, you might make some, erroneous mistakes, which your eyes may not catch. But when you start running the code, you see errors. When you see errors, don't fidget, don't be scared. All you need to do is to go back to your code and check the characters, check whether you have formatted the syntax the way it's supposed to be. Maybe that is why you are not getting the right thing. But if you still continuously have errors, please take the errors and share it in the Slack, in week 1 Slack channel. Please, in week 1 Slack channel, don't go anywhere else and go and start asking questions. Go to the week 1 Slack channel and post your questions. Okay, so if you're navigating this, you will see how to, write a variable, how to define a variable, how to, print them, examples and the rest of them, and, things like that. And naming a variable, we've taken our time here to mention how the rules for naming variables. I think I did see a question asking what are the recommended ways of writing variable names that are descriptive. And I think I did like that question because it does show that it's okay. So examples have been given to you. Like, for example, a star name. Star name, one word might not necessarily sound so well, but because those are two different words. But when you now say star underscore name, underscore is usually one thing that is very common to, if you want to make your variable names descriptive, you tend to use underscore very well. You don't use space when creating a variable name. Python does not recognize that. It doesn't like space within a name. So have that at the back of your mind. And again, there are inbuilt Python keywords or functions that you cannot use to create sorry, just a moment. Let's try one. You can see here, we have class. We talked about class today. So let me say class. If I say class, you can see Alpha Centauri. Class is an inbuilt function, a keyword in Python. It is used to create an object in Python. So it's going to confuse it. Now let's run this. It throws an error, a syntax error. Why? It is not because the value you are trying to assign to class is wrong, but because you are using a word that has been reserved for Python. So these are some of the things that you need to take care of. So here I can come and change this to, like, say, star name. And boom, it runs, no problem. So we have data types. We have the integer data type, which allows you to represent numbers, whole numbers, negative numbers, positive numbers, or zero. And then here's an example of how to run one, a number of features. We have floating point numbers where you present numbers with decimal points. This is how to create one. Many of you who are familiar with coordinates in astronomy, and even whether astronomy or not, if you did geography, you understand the concept of longitude and latitude. You understand? And it usually one runs from 0 to 360, the other ones runs minus 90 to 90, and the rest of them. So in astronomy, we also have coordinate systems. This is how we represent stars, how we represent objects in the sky. So the right ascension, it's more like equivalent to you referring to longitude, and then declination is also more like equivalent to, like, say, declination, is more like referring to latitude. And in this case, we have assigned this variable. So now you can sense that this is a data type here is a float. Now, maybe as a beginner, you wrote this and you are confused. You don't know what type of data it is. You can just use the type function and say RA. Watch, it is going to print that this is a float data type. We can do the same for num features. It's going to tell you that this is an integer data type. And then you have the string. This is where you represent all manner of characters. You put them in a string, in a quotation character. You understand whether it is single or double quotation or even triple quotations. And in that case, you can have any kind of text. So we also have ways of manipulating. We have a different notebook that is specifically for strings. Then we have the Boolean type, which is for representing whether a value is true or false. But please, you have to pay attention to the case sensitivity here. For you to the Boolean, we have true or false. True is in capital letter. The T in true is in capital letter. The F in false is in capital letter. So these are what you have to pay attention to. If you do this, good and fine. Now, if we come and do this, because again, I need to point this out, and I say true. It's going to assume that this true is a variable and it has not been defined. So it's going to throw a name error for you. So the point I'm making, I'm still saying it again, Python is case sensitive. So be sure that you are typing the exact character. So you need to be conscious about anything you're typing in your code environment. So we have the list. A list, a collection of items, which I explained before, that are mutable. We have two examples here. We have coordinates here where we do have a coordinate that just represents two numbers of right ascension and declination. And we can call it out here, and it prints for us. It prints these two values for us. Then remember I said something about list comprehension. So this is me just playing around. Supposedly I do this. I can say I for I raised to the power 2 in this. I think this should be correct. Let's see. So okay, yeah, I see. So I think this should work. So what we have done here is simply saying square all the values. Remember in the operators, I told you that double star together is equivalent to saying raised to power. So in this case, we are saying raised to power 2. That all the numbers in coordinates, I want you to square them. You understand? For each of the items in coordinates, please kindly square them for me. It gives a square for all of it. You can change it to 3. It gives you a raised to power 3 value. So these are some of the things that Python can do for you. We have the dictionaries that are a key value pair. So when I was explaining earlier, I did talk about the fact that, where you want a case of defining something, a name, a star name. What is the magnitude of the star? Maybe say 0.4 magnitude. What is the type? It is a star. What is the coordinates? You give it the coordinates. Now you can see this is a dictionary. It has different data types. This is the first item in the dictionary. Sorry, let me see. I'm not sure if this is, apologies if you are not seeing this was tiny before. So I believe you can see it very well now. Okay, so here you see name. This is the first item, name, and then the name of the star. The second item is the B magnitude. So this is how we define magnitude, like how bright an object is in the sky. Mostly these are optical ways of defining magnitude or the brightness of an object in the sky. So this is a relatively bright object, 0.4 magnitude. What kind of object is it? It is a star. Where is it located in the sky? So this is the right ascension and this is the declination. And then if you define this, and then you define it and then you run it. You run it and Python already records this variable name. You can call it anytime. You can say print. And then it prints this information for you. You can see this is a dictionary. Alpha Centauri, BMAG, ICSI. It does contain the other things. You can call any of the methods. You can also say what type of object is this. It's telling you that this is a dictionary type of object. So these are some of the things that you can do in Python. And then we have the escape character for helping you understand how to represent text. It's really when you are dealing with strings. So in this case, you have this. You have print hello world. This is Python script. Then pay attention to the characters here. You're going to see, I think sometimes, apologies, I'm not sure if I'm correct pronouncing this very well. I think it's supposed to be like this other one is / and this is more like a backward slash. And so what this is saying is that please print hello world. When you get after this character, after this /n, kindly print the other text in a new line. So that /n simply say a new line. So this is going to be hello world. This is a Python script. It prints it in a new line. If this /n is not there, it is simply going to print everything in the same line. You can try that, or you can try it yourself. You can try it yourself and see the changes. Now, if you want to create a tab, maybe you are dealing in the case of formatting a text, you know, each time as a writer, or you are writing say you are writing an essay, or you are writing a letter, you are writing a proposal. Sometimes you need to format your text so that people can easily understand blocks of your text and see how they relate to each other. Maybe if you want to start a new contest, you say you want to create a what, you create a paragraph, right? Now, in that case, you can use the /t to create a tab. So here's an example that says this is the first line, and then the /n, backward /n tells it to start a new line, and then /t tells it to indent that new line. So this is what some of these things, this is what you can do in Python. Now, depending on the kind of problem that you want to solve, one thing that I need to point out is that there are always tons of documentation by just simply going to Google and doing basic search that you can see to understand how to really, really navigate or solve that problem that you want, whether it is for text, whether it is for mathematics, whether it is for any other kind of problem, statistical analysis or whatever. Now, let's talk about, sometimes you are writing your code and you want to make some annotations. So, yeah, I think starting from the word answer, like you want to beautify it in the sense that, you know, sometimes these things can be very, very tricky. You want to make sure that you are defining or putting in a text explaining what you are saying. This is a common practice in programming because, you know, sometimes these programmings, they don't necessarily look like a text that someone can read and understand. You need to understand the foundations, the core concepts, so that you can write codes that work. But you want to also be able to write words that you can understand to help you understand each lines of code. We call them comments. We call this statics comments. You want to comment your codes. Now, how do you comment your codes in Python? If you want to comment your code, you're going to use the hash key or the hash character. So it's usually Some of you know this hashtag. I don't know I can't remember. I know it sits in different positions in the keyboard. Sometimes, most times you can see it in the 3 keyboard where you have to press the shift and 3 button and then it displays. On my own computer, that is where it is. You have to search. This is what I'm referring to here. Hash. This is the hash character. You can also see it here, the hash symbol. So that is how if you put hash, Python will look at it and leave it. It's not going to throw an error. It's going to read that line as a comment. So the hash can come at the beginning of the line, like this one, that says this is a comment, or it can come after the line of code. So this is an example of defining what a variable saying num points, showing taking the value of 120. And here it says this is an inline comment. If I run this, I've run it now, it did not show any error. You understand? So these are ways of beautifying your codes and then looking at how to write comments. Even in one of the examples, then some of the examples in the notebooks, you see that even in the code lines, some text are also provided using this hash so that you can get a sense of what is being said. And I think I do have an example in the slide here. Let's go back to the class. Yeah, so you can see here, you can see these are hash. There's a hash character here showing that, oh, these are comments for you to understand what the code is doing and the rest of them. So, and then here you have operators, which I think I explained operator. These are how you manipulate values, how you manipulate data in Python. A number of them, the normal mathematical operators are listed for you. And then you can see examples are provided. And all you just need to do is to run this. You can also, please, while you do this, play around, change the values and see what happens, You can create your own relationship, do the tryouts, all of these things, plus, minus, multiplication. They were all done here for you. And then, create new cells, just click the plus button, you create a new cell, and then you perform those operations yourself and see what it gives you. So these are different examples. And we have used the print in such a way that while you run this, you will be able to do what to also display and see the results. Format the text, okay? And then you see what is happening. If you have any question, please put the questions in the Slack while you are navigating this in case you encounter an error. So we do have all of these things. We have the comparison operators, the equal to, less than, not equal to, greater than, less than, all of these things. You can do that yourself and see what it runs for you. So this has been designed for you to easily read, run the cells and understand them, but please also try it, get your own hands dirty and write your own and see what happens. So be that as it may, I think because of time, I need to quickly run through other ones that I think are so very much important. So let's try the data structures. So I'm not opening this in Colab. I'm not opening this in Anaconda. I'm opening it in Colab. So before I forget, let me say this again. For those of you that will open this in Colab, when you are done with the notebook, you get your hands dirty. Please, this can only run when you are connected to the internet. If you get disconnected from the internet, the compute resource will die. So you have to manually restart it again. I think there's a way to do that. I think, yeah, this connects, if it shuts down, you can say connect to a local runtime and then it connects again. And the rest. So, but if you create new cells, just like I've created at the upper, you can see I have mutilated this very notebook. I've changed it a bit because I've created new cells like this thing here. I've tried my own and I want to keep note of it. All I need to do is come to File, come to Download, and download the notebook. This IPy notebook, this will download as a Jupyter notebook so that you can save it on your PC. Otherwise, if you don't do so, and you close this tab, you won't be able to recover all the manipulations that you've done yourself. So that is one disadvantage of running this in Google Colabs, and that is why I appeal to you to run it in your Jupyter notebook on your computer. So that because then any changes you make will sit in your computer, you don't have to download any notebook. You are free to modify the notebooks, put as many information as possible for yourself, try out many things. So let me open this other notebook. So you can see I have this notebook that is connected to this runtime. I've opened another one. I can still connect to this runtime, connect to a local runtime. Okay, let me do this, sorry. So I don't necessarily need to run connect. All I need to do is just read what I'm reading and then try out an example. When I get to the text, they ask me, I say run anyway. It starts connecting and then it connects. No more than 20 seconds. Shouldn't take, yeah, you can see it's connected. Now you can see I do have two notebooks connected to the compute. So these are not heavy notebooks. They are not taking a lot of memory. Neither are they taking a lot of processing memory. So they are not taking a lot of processing memory or storage memory. So it can run. All of them can run. Yeah. So I have run this. And then you read this, play around, look at it, it's a common tuple methods. Yeah, common tuple methods are here, the counting that goes to count this. So I think I've defined this very tuple. Let me print it so that we'll see how it looks like. Remember, if you want to print something, you just, oh, sorry. Okay, I think this has become so big. So I can do print and paste in the name and then it prints for me. Now, if I want to call a particular value, I know there are two values here. If I want to call a particular value, you can use the slicing method. We usually call this slicing to get the first value. In this case, our first value is point to 0. The index in Python starts from 0. It doesn't start with 1. 1 is the second value. So for me to point to this first value, I have to call 0. For me to point to the second value, I have to point 1. For me to point to the 10th value, I have to enter 9 in this slicing. So have it at the back of your mind when you do this. I think I did mention it here in this text. So now if you want to try out this method, you can say, oh, well, I think source code is defined as source codes, and then you want to try this, you can just say, you can say dot count. Okay. So if I want to see how many values that are in this, in our case, we only have just 2. Let's say I want to play around. I create a new tuple. I can say, okay, I can say source values. Then I create a tuple. Here I can say 1, 3, 5, 0.7, 5. You can say 6. You can say 2. You can say 4. Say 6. So, as many as possible. If I've created this now, I can have these values. I can print it out. You'll see these values. And then I can say something like source that count. And then I say, maybe I want to see how many number of times. Okay, which value here appeared twice? Okay, 5. Let's try 5. So we have 5. 5 appeared twice, right? It appeared twice. If I want to see where, let's say, let's try this and see what it gives us. So I know in this value, I have 0.7, but I've forgotten exactly the position where it is, where it lies in this tuple. How do I get that? How do I know this position? Let's say this is so long. Let's say there are 200 items here, and I'm not able to navigate to know where each of these values fall, which position they fall in. So the best way to do this is just to use the dot index, and I pass in the value. It tells me, oh, this is in position 3. So how do you know that it is in 3? If you look at this, this is 0, 1, 2, 3. So this is how Python works. So you've tried out these methods. Now in list, I've explained what list is before, and I've explained how it can, the reason why we use list and the rest of them. So this is a list that contains the coordinates of a data type. Now, if you pay attention to this example here, it is different from what is in the slide. We did have just basic example that is just maybe a string or a value. In this case, we actually have another kind of data type. That is here you can easily sense that there are 2 data types in this list. What are they? Float data type, which is in a tuple. We have 2 float data types in a tuple, and then the tuple is saved into this. So this is more like showing you the complexity of how data can be represented and how you can still manipulate them. Supposedly I run this. You can run this, and then we have these values. If I want to call out the second item, I just need to do, how do you call out the second item? 1. Remember, it starts with 0. So if I run this, it's going to print out the second item for me. If I want to see the type of value, the type of data the second item is, I just need to use the type. It tells me that this is a tuple, right? It tells me that this is a tuple. If I want to call, I know this is a tuple, right? If I want to see the values, maybe I want to point out a particular value in that tuple, maybe the first value. I can slice again, and here it's going to tell me that it is a float. So now this is referencing 101.2875. A good way to see this is, let's put this thing side by side. We can type this here and put a comma, separate it. So this first one is going to tell us the value, and this is going to tell us the data type. If we run this, we're going to have the value itself and the data type. Now, I do appeal to you to play around this. This is where you begin to see how data manipulations work in Python. Maybe you can even have arrays of numbers, and you want to go deep into the array and fetch a particular data point. You understand? So this is very, very useful. Get your hands dirty. So these are examples. These are different methods in list for lists and how to, like, these are examples like this. You can either define this, you can also copy this and run it like this. Let's say this one. If I copy this and I run it here. So this is a list. But this list is not defined to a variable name, so it will disappear. Your Python will not recognize it later on if you reference it. So it's going to tell you now that this is, you have appended 3. So I can do this and say, maybe, let me just say list 1 is a list 1, 2, and then it appends 3 to itself. If I print list 1, it is going to, okay. Oh yeah, so because we did not assign it to something, so I could do this first, list 1, equal to this, and then I can come here and say list 1 dot append. Let's see if this works. The only reason why it's not supposed to work. Let's see. Oh, okay, apologies. I'm supposed to remove this first. Okay, so yeah. So I know why this is happening. The reason is because you don't need to make sure that it has the information. Okay, you can have this list 1 now and then run this. So in this case, what this is doing here is that we have assigned a list. We created a variable called list 1, and then it does have the list 2 values in it, 1 and 2, and then we append a different value into it. And then when we print it, we are going to see that initially when we created this variable, it just contains just 2 numbers. And then we have used one of the methods for list to append a value, to add additional value to it. And then it simply adds that value, and then you can print it, you see the value have changed. So this is one of the reasons why we say that list is a mutable data type, because you can change the value, you can add, you can adjust, you can change the values in the positions. So I will appeal to you to please try all of these things out. Use the different examples here that have been listed. Play it out and compare the results. You can see you're able to get the same 1, 2, 3 value here and the rest of them. And this is applicable to many other examples that were provided for you. You can see these examples were all provided to apply for those methods. Then you have sets. Here we have a set. This is how you define set. Don't mind what's in the slide. When I share it, I will make those corrections. Star names. We have these are different star names. Astronomy. And then we have then printed star names, canopies, Vega, and Siri. And then there's something that I think I did talk about that, but I'm not sure. I will see if there's an example there that it does apply to, but we'll come to that later. These are methods that can be used for sets, and a good number of them are all listed here for you. Example, we want to add a different name, Eta Karena, we've done so. We want to add multiple items at the same time, we do so. We have updated it. You can see the number has increased. We want to remove an item, we do so. We remove a particular item, put the item name. You want to just drop an item. In this case, you have removed the first item in the list. Now you want to clean up all the items. Oh, like I'm not sure I like what I have in my set anymore. I want to clear them. How do I do so? You use the clear function, and then it clears up everything for you. So I think we already did this. Apologies, maybe I should have done this earlier. You see, it tells you that this is an empty set. There's nothing inside, but it does have the set property, but there's no item inside of it. Now, this is where you do a bit of your mathematical set, where you find the union between a set, you find the intersection, the difference, symmetric difference, and taking a copy of one set. So all of these things are available for you. Then this is dictionary, which is a key value pair way of storing information. Just like in a dictionary, you say, oh, what is a place? What is a noun? You know, some of those things. What is an ion? How you define things and rest of them. So here's an example. We also have methods for manipulating this data set. And you can try any one of them. Examples have been provided for you. These things are well described, and then they're also easy to understand. But please, if you encounter any error while trying on your own self, please share it in the Slack channel. And then we do have exercises. Please, it's very important that these exercises that you do them, because this is going to help you to understand what you're doing very well. Don't just go and run the cells. Try and practice, try and understand the concepts. If the resources that have been provided is not enough for you, one more thing that you can do is to simply, just go to Google. Let's look at it. Let's say I'm confused. What are list methods? I just come to Google and say, what are list methods in Python? Let's say I'm a terrible writer, or you're not understanding, you need more. You just go there. It gives you a lot of information that you can see. You can see many articles online, blogs. Please do this for your own learning sake. They will help you. You will see a whole lot of information on Python list. You read more. The more you read, the more you better understand the context or the problems, or how to, make use of list very well. Not just list, any other problem that you have. This is how you learn. And so I think we've touched this. Let me quickly talk about loops. I think these other data structures are very straightforward. Let's try out loops. Let's see if we can open this in let's see if we can open this in Google Colab. Should be able to open. Yeah, it's here in Google Colab. Again, it allows you to get a sense of what loop is all about. It says repeating actions a specific number of times. Now, this is an example. Imagine you are told to print 1, 2, 3, 4, 5. If you want to write it, this is the way you're going to write it. But don't you think that this is exhaustive? It might work for you when you just do 1, 2, 3, 4, 5. Now, imagine I say, do this for 1 to 100. You're going to see that the window is not going to be enough for you to write. So you get tired because you even forget and forgot track, like following the track in terms of the iteration. But a simple way of doing this is either using things like for loop. Here you can see an example that says, remember I said the keyword before, range, that allows you to navigate from one number to the other. It says, I want you to run a value from 10 to 0. Many of you like watching space launch, maybe when NASA is launching a satellite or a rover into space, or even now that SpaceX is doing it with their satellites or rockets. A good thing that you usually see is that you see a counter that keeps counting down. Things like it can start from any number, keeps dropping maybe every second until the 0 points when the action has to be taken. Now, let's say you are doing so. A good example is this code here that tells you, okay, let's count from 10 to 0. So what it means is that it's going to say, you know what, keep counting from 10 to 0. I want you to sequence this by -1. So what it means is start with 10, -1 gives you 9, -1, 8, continuously like that till it gets to the last number, which is 0. If you run this, it's going to ask me to run to connect to a compute resource, which is doing right now, not more than 20 seconds. And it runs. You understand? So these and many more explanations on range, the concept of start, when to stop, what the sequence is all about. You get to understand this when you go through these notebooks. And then here we provided an example showing planet orbits and how to calculate, let's say, if this is more like telling you at what point in the day, in a year, what angle is Earth towards the sun. Things like this. These are basic calculations that you can do. You can see we simulated this for a handful of degrees. So we defined an orbital period. We say keep cycling from 0 to maybe counting to 30, and then you do this calculation for us. We want to know based on days what angle the Earth is going to be around the sun, and it typically gives you this example. These are already run already. You're already seeing the result that in day 120, the Earth is going to be at roughly 120 degrees around the sun. Towards the end of the year, it's roughly around 360 degrees towards the sun. Now, these things are very, very essential. These things are very, very key for dealing with repetitive tasks. Please kindly read the text and also the notebooks. Calculation that shows you how to, an example, searching for habitable planets in astronomy, and how to do those calculations. Sorry, a lot of printing of text is actually to help you read things that you can understand and follow. Yeah. Okay, so I think the best bet is for you to go through this, read them, play along, and that is the way you're going to learn. Let me also say this, programming is not taught mostly by just explaining something to you. I've explained the fundamental concepts. The only way you're going to understand it is if you get your hands dirty. And that is why these resources have been prepared for you in a way that you don't need to type a lot, because it could have been written in a paper and given to you for you to type. But it has been written for you to read through, run, and then practice yourself. So we do have other examples, but because of time, I'm not sure I'll be going through all that. Based on the ones that we've covered so far, I don't know if there's any question. from people online. I'm not seeing the Slack channel right now. So, okay, yeah, I'm seeing the Slack. Okay, I see. Okay, so I see somebody is making a statement. I'm not sure this is applicable now. I will look at it later, and then, but I don't know if there's any question. So let me check the chat. Okay, so in this section, lectures will happen 2 hours, not more than 2 hours. So you can see we are at the end of this section this morning. We're going to have another section in the evening, but be mindful that we may not be having these sections for all of the double section because it's more like this is repetitive and these things are streamed on YouTube. So what it means is that we already have a recording that will be shared with you for those that couldn't make it online, and then you can also go to YouTube and watch the same thing. Yeah, so I'm seeing a question here. Is AstroQuery, if AstroQuery is a package, what is Skyview? Skyview is, I think, is also a package. I think they do have a Python package for it for image query. Yeah. Okay. I'm not seeing any recent questions so far. I think these are old questions that applied earlier when we were in the Q&A section. Okay, so I see people are all looking at this. So I'm not seeing any new question. So please take your time, spend a good number of time on the notebooks. That is the only way everything I'm saying here is going to stick in your head. Go through the notebooks, understand them, make use of all the available tools at your disposal, from search engines to the notebook itself, to even some of the notebooks do have additional links that points you to like maybe reading a blog post or an article about this particular topic. These are just to help you get diverse view about the topic. One more thing is we are in the era of artificial intelligence, so many of you do have access to chat, the chat interfaces, whether Google Gemini, whether ChatGPT, or anyone that you have, or if you build anyone yourself, you can also prompt them to explain certain things to you. They can actually give you more context. Or if you have a use case in your head or an example in your head that you're still confused about, they can help you structure it. Just combine all of these things to make your learning journey easier. If you encounter any error, try and understand the error first. Don't get scared. Read through your code. Try to understand what the error is saying. Google the error. You can just take that error, Google it, and see if someone else has had that error before. Try and solve it yourself. If you spend a good number of time and then you're not getting any result, then you can share it in the Slack. Don't be scared. Don't be shy. You know, if you can spend 10 minutes, if you're not getting the result, put it, somebody else who knows the problem might point out the error for you, and then you can continue. But please don't get scared because you encounter an error. Don't get scared. Don't be shy to ask questions. And this is why we have in this community. And I'm also grateful to everyone who have been helping to answer questions either on Slack or in this chat interface while we'll have these conversations. So please, I'm going to say thank you for joining us this morning section. And then, okay, I see Edina wants to ask a question. Yeah, you can go ahead. Edina, can you unmute yourself?
Hello, sorry about that. I was trying to unmute, but I was having some trouble.
Okay.
Okay, so my question is, or was, when we are editing this code right here, or trying to to play around with it in the notebook. Will it now, like, if I'm editing on my part, will it affect someone else's? Because I'm assuming we're using one this GitHub.
No, it's not going to affect anyone else.
Okay.
So so that's one thing. Let me just show you here. You see, I've edited this, right? If I close it, it doesn't change here. It doesn't change. So it doesn't change, neither for you nor for myself. It's not going to change because this GitHub is not connected to that cloud interface. So any changes you make is not going to be applicable here. But if you think that the changes you are making will be very useful for you, this is more like your homework. You are doing some exercises, so you need to keep track of what you have done. I will advise you, when you are done, just click the file and download that notebook and keep it in your laptop. You understand? That is where you have done a lot of work. Otherwise, if you don't and you close it, like you said, and I've closed one notebook, I've lost every changes I've made there. So if I maybe I can't find it anymore, there's no way I can recover it. But if you are doing this in your machine, you're running this notebook on your computer, then those changes will sit on your computer. It's not going to sit, neither is it going to sit on GitHub. You understand? So this is just for you to access. Everybody have access to this. Whether people in this have access to it, whether those who do not also have access to it. Okay? So do not be scared or worried. One thing I can ask any of you to do is, I'm not sure if that is possible now. There's a way to do this, but for whatever reason, I'm not finding it. There's a way to start a GitHub repo. Any of you can start the GitHub repo if you find the information. Yeah, this is it here. I can see 10 people have started. If you find the repo very useful, please come and start it. If you find the things you think what we're sharing here is very useful for you, please just click the start to rate it that it's a good work. So I think that is what we need to do. But I think we're going to end the section here. Please spend more time on the Jupyter notebook. That is the only way you are going to understand it. Get your hands dirty. You don't learn programming just like you learn calculus in class. Even calculus or mathematics, after the lecturer is giving their lectures, you still have to go home and try to do the derivations yourself. So this is applicable in programming, Python inclusive. Anything that has to do with code, you have to get your hands dirty. So please do get your hands dirty, and I think that's the only way you succeed in this training. So I think on this note, we'll end it here. Thanks for joining us. Please also form communities, like I said before, form communities on Slack, ask questions, even bring other things. If you think there are other resources that explain things way better than I do, or you think would be useful for the community in this topic, please bring them, share them in the Slack community, right? Please. On this note, I'll thank you again for joining us this morning. And then, oh, thank you, Eugene. That's a very good example. You said, create a copy of the Google Colab. So you can actually create a copy of, you see, that is why I like people who bring ideas. You can actually create a copy of the Colab. So if you do this, you can save a copy of the work that you have done in your Google Drive. I think this is a way to do so. If you click save a copy, I think this should work. Save a copy in Drive. It's going to create a copy of all the changes that this particular notebook and the changes you have made. And then you'll be able to access it in your Google Drive later, right? So you can see it, I said copy of this. So if you go to your Google Drive now, you'll be able to access this, including all of the changes that you have made. Thank you very much for bringing that up. It skipped my mind. Yeah, this is why it's good to have more people, share ideas. It helps. It does help a lot. So please do have a nice day, and we'll meet again this evening for those who did not join this section. And then also invite your colleagues to also go through those resources, get your hands dirty, share ideas together, and hopefully in the next few weeks, we'll see what you'll be able to do with what you have learned in this course in your project. So on this note, do have a nice day. Bye, everyone.
Bye.
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 Bye.